Guys, lesson 2, straight line motion, connecting position, velocity, and acceleration. We've already done some of this. You already know some of the connections about derivatives and all that. So looks like we talked about back in Unit 2, Lesson 7. We talked about it a couple times throughout the year. Okay. So the big ideas of position, velocity, and acceleration were introduced. Particle motion problems deal with, this is motion along a straight line. So not following the graph, but motion along the straight line. Includes horizontal and vertical motion of a falling object. And that's what I just said. Motion means particles moving along an axis, not along the graph of the function. Okay? Now, I don't know, there's a lot of vocabulary here, right? Most of these things we've talked about at some point. Maybe I'll just kind of skim through them real quick with you. But they're going to be here for reference, right? So position, S of t, x of t, y of t, tells where the particle is located at a given time t. We usually see s or x. Average velocity. So average velocity, or in other words, average rate of change, is change in position over change in time. So displacement over elapsed time. Instantaneous velocity. Instantaneous velocity is our derivative. So that's s prime of t. It's the rate of change of position at a given time and direction of movement. That's our derivative. Speed. We talked about speed, right? Speed is absolute value of velocity, the rate at which the position is changing. Acceleration is second derivative of position, or first derivative of velocity, tells how fast the velocity is changing, and the sign tells if the velocity is increasing or decreasing. So positive acceleration, velocity is increasing. Negative acceleration, velocity is decreasing. Displacement over an interval. That's just how far from where you started to where you ended. Okay? Difference from start to stop. Distance traveled. Okay, distance traveled is everything added up. The sum of the absolute values of the distances between turning points. So if you go right, left, right, left, right, left, and you end up back where you started, distance traveled is not 0. Okay? It was adding all those distances up that you traveled. Free fall motion. There's a basic position formula there. 1/2 gt squared plus v naught t plus s naught. That's the motion of an object under the influence of gravity. Okay? Where we worked with this equation a little bit earlier on, I think in some word problems. S naught, or I say S naught. What's Mr. Kevin say for that? No?
S naught?
Yeah, I say it's S naught meaning the initial position.
It's initial.
Oh, initial, yeah. V naught, so V in the little 0, initial velocity. Okay? And G is gravity. Okay? Whatever your gravity is. Direction changes. Velocity changes either positive to negative or negative to positive. Velocity does not need to pass through 0 or even be defined at a point where its sign changes in order for direction to change. And then gravitational constants, 9.8 or 32. Depends. Are we talking meters per second squared or feet per second squared, right? Okay. So, our plan is to make the connections between position, velocity, and acceleration. We're going to look at this and, work on our explanations and how they all connect. So, example 1. A particle moves along the x-axis so that any time t greater than 0, so any positive time, the position is given by that. At t equals 0, determine whether the particle is moving right or left. What do we need to know? We have no velocity, yes? Okay. If velocity is positive, it's pushing the particle to the right. If velocity is negative, it's pushing to the left. So how do I find velocity? We're going to do the derivative of position. So derivative of t cubed, 3t squared. We got these basic derivatives, right? 9/2 t squared multiplied by 2, and it's 9t minus 12. We want to know at 0. So velocity at 0 is going to be negative 12. So what do I know? The particle is moving left because the velocity is negative, right? Particle is moving left, since I can say b of t is less than 0 if you want. That's the official, I've been doing that all year, right? V of t less than 0, that's the fancy way of saying negative. Okay? And that would be, you know, what AP readers are going to expect you, you know, they're going to expect that type of notation. So, okay, B. At what time does the particle change directions? What do we need to know here? When velocity is 0, yes. And didn't we just find a velocity equation? Yeah. We know velocity is 3t squared minus 9t minus 12. The particle is going to change directions when that velocity is 0, because that means it's a brief or long, but pause or stop, right? If you look carefully, all three terms, you can factor or divide out a 3, which makes this much better, doesn't it? And it is an equation, so you can divide the 3 out altogether. I opted to factor it out. T squared minus 3t minus 4 will factor, yes. T squared is t times t. Multiplying to be 4 in this scenario is going to be 1 and 4 minus 4 plus 1. So if I solve that equation, what does t equal? 4. Okay. T equals 4 and t equals negative 1. As opposed, like in terms of, okay, I don't even have to plug in here. Think about the context of this problem. What are these numbers?
Time.
Time. So what do I already know?
There's not a negative time.
Our context is time. There is no negative time. Okay. Yes, it was an answer, and it is a valid answer to the problem, but not in this context. So not technically extraneous, just not an answer we're going to use here. Now, it does say to justify your answer. Okay. So we know that when velocity equals 0, that's when my particle is going to change directions. To justify it, an option to justify would be to look and see what's going on either side of that time. So like we just found that the velocity at time 4 equals 0, yes? So if we look at the velocity on either side of that time, that can help us to justify. As in, what is the velocity at time 3? And what is the velocity at time 5? Now, I picked nice, neat whole numbers. If you want to get technical, you could have used 3.9 and 4.1, right? those are numbers right on either side of 4. But you just need numbers in general on either side of 4. So we plug in 3. You want the shortcut? I have that it's negative 12. You plug in 5. I have that it's 18. I don't know if you're waiting on me or if you'd already worked that, but you're probably waiting on me, right? Being lazy. Now, does that justify? Yeah, because before 4, so at 3 seconds, it was a negative velocity. So the particle was being pushed left. At 5, it's a positive velocity. The particle is being pushed right. So, at t equals 4, the particle changes direction. From left to right. And, I mean, I could also mention that v of t changes from negative to positive at t equals 4. I don't feel like you'd have to have both of those pieces, but that's the idea of what's going on there. Okay? Start looking at C when you're ready. At t equals 1, the velocity is the velocity of the particle increasing or decreasing? Explain your answer. Well, how do we decide if the velocity is increasing or decreasing? What do we have to look at? Acceleration. Okay. So, I just changed screens so I don't have it anymore in front of me. So you have velocity up above, right? So we're going to look at the derivative of velocity, which is acceleration. Derivative of 3t squared minus 9t minus 12 is going to be 6t minus 9. So that's acceleration. We want to know at time 1. So acceleration at time 1, 6 times 1 minus 9. So that acceleration is negative 3, which is the derivative of the velocity, right? So when we talk about something increasing or decreasing, we're looking at the slope of it, right? So that's why we're looking at acceleration, because slope of velocity is acceleration. And so what is my velocity doing here? It is decreasing because that value is negative. So the velocity at t equals 1 is decreasing since I'm going to say a of t is less than 0. And that's why, okay, so in my notes I actually have a of 1 is less than 0. But I did define t to be 1 here, didn't I? So either way it would work. Okay. D. At t equals 1 is the speed of the particle increasing or decreasing? You guys remember talking about this? This was probably back in that chapter 2 lesson we talked about. I don't think, the only way it talks about speed on the back pages or on the front of this page is just it's the absolute value of velocity. Do you remember how to tell if speed is increasing or decreasing? Or let me phrase it a different way. Is it speeding up or slowing down? I don't remember exactly where it is, but I know we talked about it. There was a chart we filled in even. Probably in
144.
I was just going to say 147. I just found a chart. There you go. Yep. 144. We talk about is an object speed increasing or decreasing. It's all based on the signs. If the signs of the velocity and acceleration are the same, your object is increasing, so speeding up. If the signs are opposite, they are decreasing. Okay, so that is on page 144. So, side note there, page 144 is helpful. Because I'll be honest, I had to pause and think on this. I, already moved on and forgotten. So, let's see. What do we know? Do we already know the velocity at 1? We have not found the velocity at 1 yet, have we? So, the velocity at 1, 3 times 1 squared minus 9 times 1 minus 12. And that's going to be negative 18. We just talked about the acceleration of 1 up above. And the acceleration from that previous part is negative 3. What do you notice about these? Negative 18 and negative 3 have the same sign. And so speed is going to be increasing at t equals 1 since they are both negative. Speed is increasing at t equals 1 since velocity is less than 0 and acceleration is less than 0. Or in other words, same signs. Okay. E when you're ready. What is the particle's acceleration at t equals 1/4? Explain the meaning of your answer in terms of the particle's velocity, and how would units be explained in context of the particle? So, okay, easy part, acceleration at 1/4. So we're finding a of 1/4, what was my a formula? 6 times 1/4 minus 9. I'll be honest, my brain's this morning 6/4. 6/4 is 3 halves. 1.5 minus 9. And I did negative 7.5 then. Now, I will say when I checked against the answer key did an improper fraction, and they used that sum in their explanation, if I recall. Yeah, so, because if we thought about that way, 6/4 would be 3 halves, minus 9 is 18 halves, if you will, right? So, there you end up with negative 15 halves. As I said, personally, when I did this on my own, my brain went to negative 7.5. you know, however you're going to get there, one way or the other, right? Okay, so that is the first answer. The particle's acceleration is negative 7.5 or negative 15 halves. Explain the meaning of your answer in terms of velocity. In terms of velocity. So what is the velocity doing here? Decreasing, right? Acceleration is negative, which means my velocity would have a negative slope at this point. So velocity is decreasing. And then we'll have to talk units. Particle velocity is decreasing. And I just say decreasing there. I mean, you know, technically it's because the acceleration is less than 0. So I can say a of 1/4 is less than 0. How would units be explained in context of this particle? Let me ask this. How do we talk about units of acceleration?
Meters per second squared.
Meters per second squared, right? Or do you guys also sometimes hear meters per second per second? Okay. And so, I mean, that's the basic gist of what I saw in the answer key, because that's what I was trying to decide is, okay, where else can we go with this? If you look at it as a fraction, the 15 halves, okay, if this is acceleration, it's the change in velocity, right? So over the change in time. Velocity is going to be distance divided by time, and this is divided by time, right? Change in velocity over change in time. Velocity is distance divided by time, divided by time. And so that is when we talk about distance per time squared. We don't have any units necessarily here, I don't think, do we? I haven't seen any units there. So, and if you use this idea of d of t, divided by t, well then d divided by t, dividing by t is multiplying by the reciprocal, so multiplying by 1 over t, and thus you get your distance divided by time squared. Okay, that's obviously a good stopping point. Got a lot to do tomorrow, guys. A lot. Okay, so we will look at a table question. We're going to look at a graphing question, and then we're also going to use the calculator some. Okay, so being able to use the graphing or calculator to find all the different information, which is something I plan to try and brush up on before tomorrow.